In this video, we're going to take a very quick look at a very important concept in higher level mathematics, and that is finding the zeros of polynomial functions and exactly what we found when we found them. So, if f is a polynomial function, then values of x for which f of x equals 0 are called the zeros of f. These values for x are the roots or the solution of the equation f of x equals 0. Each real root of a polynomial equation f of x equals 0 appears as an x-intercept on the graph of f. So all those solving polynomial equations, that is exactly how we're going to find the zeros, and what we have when we find those zeros are our x-intercepts. So the x-intercepts, the roots, the zeros, the solutions, they're all connected. So let's take a look at a polynomial function and see if we can find all those zeros. To find the zeros of the function f of x equals, first identify the fact that it is in fact a polynomial function. Then as a function, if I want to find the zeros, I let f of x equal 0. Now this looks exactly like a polynomial equation from a previous chapter. So now I'm back into repeating myself. Since there are 4 or more terms, I'm going to factor by grouping. So as always, because I'm lazy, I try to group the first 2 together. And this question was brought up earlier today, so I want to repeat it. Why do I know I want to group 2 by 2? Because 3 of the guys have x's and there's no 4th variable. If this were x to the 4th plus 4x squared minus 16 plus 5y squared. That's when I want to look and see if I need to group by 3 terms. But since they all have x's except for this poor little constant, I'm going to try the 2 by 2. So having grouped them like this, now I'm going to factor out an x squared from my front grouping, and that leaves x plus 2. From the back grouping, since I want the x to be positive, I'm going to take the negative with the common factor of 4. So I'm going to take out a negative 4, and that will leave x plus 2. Now my parentheses are identical, so they are a common factor. So I'm going to factor out the x plus 2. And when I divide him out, that leaves me with x squared minus 4. X squared minus 4, since it's solving, I can chunk it, or I can go ahead and say the difference of squares gives conjugate pairs. And here are my conjugate pairs. Okay? So according to this, I've got 3 guys multiplied together to give me 0. So one of those 3 guys has got to be 0. So either x plus 2 is 0. I'm not going to write him out a second time. Or x minus 2 is 0. So x is negative 2. Or x is positive 2. So I have 2 zeros here. One at positive 2, one at negative 2. And again, we're going to look in a minute and we're going to note how these are zeros. They are solutions to f of x equals zeros. They're what we call roots. And they're also going to be my x-intercepts. To show you what exactly it is that we're looking at, okay, this is the same function. We found our zeros to be negative 2 and positive 2. So here's negative 2, 0, and positive 2, 0. Those are my 2 x-intercepts at negative 2 and 2. The graph shows the function, and note that each 0 happens to be an x-intercept. The graph touches the x-axis at -2 and turns, and yet it passes through the graph at +2. There's going to be something very important that's going to tell us which one of those things happens in the very near future.